This is a story of Boston University's first journey to the lunar surface.
LEXI, are we going to execute 5.14 with a high voltage value of 1000?
Go for 5.14 with a high voltage value of 1000.
Copies.
Right now we're at about 75 miles above the lunar surface is what the altitude of the spacecraft is right now going around the moon. We've got 2 propulsive maneuvers left. There's one on Sunday, 3 days from today. And that will lower the altitude of the orbit just a little bit more, so it's pretty low. And then after that, there's only one more, and that's to go down. For the last 20 or so years, my research has been focused around studying the space environment around Earth. And in 2019, we had a fantastic opportunity, and NASA announced that it was going to be putting commercial landers on the lunar surface, and they were looking for payloads. And so we raised our hand, we put in a proposal for what we thought was a really compelling idea to study the space environment around Earth, actually from the lunar surface. All right, so good morning. This is a start. Very excited to get going on the LEXI project. The telescope we're developing is called LEXI, and it stands for the Lunar Environment X-ray Imager. The LEXI telescope will sit on the surface of the moon. It will be bolted to the lander. It will look back at the Earth, and it will measure for the first time the edge, the boundary of the Earth's magnetic field. Right now we have a plastic version, a 3D printed model of the LEXI telescope that we've affectionately called Plexi. And of course we're trying to get things built as soon as possible, and so we've been creating drawings and running them off to the machine shop and talking with the folks there about how we can machine it the best way and use the best materials possible.
So these are all set to go?
Set to go. Let's do it. We don't have a huge amount of time. It's actually very short for a space flight program. Right now, just began a new semester at BU. It's September 2019. We need to get this thing ready to launch in probably June 2021. Much of the construction of the project is going to happen in the next couple of months.
Some breaking news now. We're following the coronavirus outbreak. A new case in the United States. It's in Massachusetts. The federal government on Friday declaring a public health emergency.
This project started in fall 2019. Of course, early 2020 is when everything kind of fell apart because of COVID-19. One of the things that was in our advantage was a lot of the work we do is in clean rooms. And so that's a pretty clean place in general to work. We're already going to be wearing masks and personal protection equipment, PPE, anyways, and so some of the things worked okay with some of the restrictions. But it was very challenging to have the whole mechanical structure of the telescope built. Once that's complete, however, there is a battery of tests that you must be able to prove the instrument can go through to show it will survive and make it to space and be able to operate. So going through this battery of tests this week, we've been working on this for a little over a year now, and being able to get to this point, it's a big milestone for us. Monday we did vibrational tests. When you go through a vibrational test, when you actually physically shake things, you shake it pretty hard as if it was being shook by a rocket. There are always moments of fear when going through any environmental testing, particularly violent environmental testing, and it's really a survival test. Does it fall apart? Yes or no? It did not fall apart. Today is Wednesday, we're back again, and today is dust testing. When you land on the lunar surface, you get this big cloud of dust that gets kicked up, and if you have very sensitive lenses or optics, when that dust settles on it, that could be bad. And we're going to be testing by kicking up dust in the air, and we have sticky pads inside where our lenses would be. Our hope is that no dust gets through, and then we'll have passed the test. We've done all the modeling and planning, but there is no replacement for actual tests. Part of building large projects is the team, and this is such an amazing team to work with.
My name is Katriana Pa'u, and my role on the project has always been a PhD student, which means working on all the little things that need to be done.
My name is Caden Connor. My role on the LEXI team for the past 3 to 4 years has been sort of just as a payload engineer, whether that be testing, designing, manufacturing. That's what I like to do. Part of the journey has been figuring out where can I contribute the most? How can I still support the team when it's needed?
A really innovative part about LEXI is the lenses that are being used. We're using these pieces of glass that are slumped or bent over a curve, and they've got all these little tiny holes in it.
So the lenses we are specifically working with are referred to as lobster eye optics. So the big thing about these optics is that they can take X-ray images.
Unfortunately, though, with innovation, we also have this being a very scary point for us, or a point of high risk. Something goes wrong and one of them breaks, it can be really significant.
The optics, that was really stressful. I remember almost being happy that the cat was the one doing it.
I was extremely scared that I was going to mess it up, not knowing exactly where the edges of what can I do that might break this. Good.
It's great, Kat.
Yay.
This is fantastic.
A thumbs up for the Zoom peeps.
Once we had those optics in, the team was excited, ready to run off and mount it to the lander. But at this point, there was actually a bit of a stop.
You don't need the computer anymore.
Yeah.
So there's the Ethernet cord.
I would just rather not have to.
You don't need the compressor cable under there anymore, so we can undo that cord.
I've been involved with LEXI since the LEXI mission was selected back in 2019. The LEXI instrument itself was developed pretty efficiently, but then there were some delays on another end. Throughout that time, I went from a graduate student to a postdoc to a research scientist.
The timeline of the LEXI project is interesting because it's the timeline of building this telescope that we put together, and then there's a timeline of another group building a lander. Our team is working very closely with a company called Firefly Aerospace. Firefly Aerospace is a company that's developing the lunar lander while we're developing a payload in parallel. The lander wasn't quite ready. There were a number of things still being developed on the lander. And so the agreement we had with the lander was, okay, we'll keep it here in Boston, we'll take care of it, and when you're ready, let us know, and we'll come and bring it over.
Well, you don't need to photograph the channel.
What do you want me to photograph next? What's on the checklist?
Handle side with that.
So we're here outside of Austin, Texas at Firefly Aerospace, and this week we are integrating LEXI with the lander.
So if you two want to get gowned up and start prepping things in there. My name is Russo Nutter. I got my master's in mechanical engineering at Boston University, and during my time there, I've been working with LEXI every day, hands-on every day.
Once we got there and we chatted with LEXI and made sure everything was going okay on the bench, the next step is putting it on the lander. The mounting was hard. Holding from different sides. Several people needed to climb up and reach over the deck of the lander to actually mount LEXI in. It's almost a dance. If somebody dropped the payload or slipped or had to scratch their nose, there's a lot of human elements here that could cause a lot of really bad damage both to LEXI and the lander. And so there were certainly moments of a lot of stress. When all is said and done, LEXI was being held up by several people. The mounting screws went in, and now LEXI is comfortably sitting on the very top of the lander, perched to take wonderful view of the lunar surface as well as Earth space environment. The next step is launch.
You're looking live at Launch Pad 39A, where in just a few minutes, SpaceX will begin fueling its Falcon 9 rocket. At the top is the Blue Ghost lunar lander, built by Firefly Aerospace with NASA payloads on board.
Hi from the LEXI Operations Center. This is Emil manning the Ops Center here while the rest of the team is at launch. It is almost 1 o'clock in the morning as we wait for launch here.
Our launch was in the middle of the night.
Some of our team went to watch from a VIP area in a special place with a whole bunch of politicians and people from the launch team.
We were fortunate enough to be less than half a mile from it.
It was a perfectly clear night, had the moon in the background. It was very poetic.
I am watching launch on my laptop here.
There were other members of us, including me, that watched from a bridge. And this bridge was a couple of miles away. We had our friends and family with us. We eagerly waited in the cold and excited, nervous, lots of strong emotions coming up.
That's our communication center right there. Tell us that we have about a minute left to launch. My heart is pounding. I can't wait to see this thing go.
It's hard to put into words. It was my first ever time seeing a rocket launch.
When you see something like that, every scenario goes through your mind, not least of which is what if rocket goes boom?
Launching rockets is still really hard. It could blow up on the pad. Even if the lander was perfect, that just wipes everything out.
It was a hold your breath moment.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Vehicles pitching downrange.
T plus 30 seconds into launch, Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center.
This is definitely a surreal moment, watching as a payload that you built and spent years developing gets launched into space.
Oh my God, they did it. They did it. It's still in one piece, as far as I can tell.
Stage separation confirmed. Fairing separation confirmed.
I was envious of the team who was at launch, but as soon as it launched, I was here on the ground station, and I realized this is where I wanted to be.
Firefly Blue Ghost, separation confirmed.
When you work on something for so long, you watch it disappear over the horizon, and the only time that you're ever going to hear it again is from the data.
LEXI, this is payload on NASA.
This is Lexi on NASA. We are present.
Copy, thank you, LEXI. Yeah, like I said, we're still tracking T-minus 40 minutes until the operation, but we might get started a little bit ahead of that. So just want you to stay on call.
After launch, the first fear, of course, is first contact. We want to make sure the lander powers up and can communicate with the ground. And there are spacecraft that aren't able to communicate.
LEXI, this is payload on NASA. Are you ready to proceed with LEXI power on?
This is Lexi. Power on is a go.
Copy, thank you, LEXI. Hold for power on execution.
Lexi copies. We see a power on.
Copy, thank you, LEXI.
It did turn on.
Turned on.
It not only took a command, but also is giving us back stuff, which is huge.
That was the moment we knew that it was talking, and that's kind of the most sensitive point. If it turns on safely, chances are we're going to be just fine shape for the rest of our journey to the moon. The flight from Earth to the moon will take about a month. During that month, the operations will be done by the LEXI team. The LEXI team will be here in Boston looking at live feeds, sending commands to LEXI to operate to move into different modes. As we're commanding the spacecraft here and talking to LEXI, we're monitoring a whole bunch of things here. How are things working inside the telescope, as well as the data rate.
I'm a physicist by training, so my role is like looking at the data. So after LEXI was in space, the data files started coming and I got so excited.
When we're on an ops shift, we're here about 6 hours. You have to be focused, like you are dialed in.
Being on ops is also a special feeling too, because you feel kind of tied in with the spacecraft.
For us here at BU, this is the furthest instrument that we've put out into space. So it's experienced environments that we have never built anything for yet.
And along our journey from Earth to the moon, we had cameras on our lander as well, and we started seeing pictures.
We feel extra special because Blue Ghost has a camera on it that faces directly to LEXI.
Lexi is on the top deck of the Firefly instrument. So every time a picture is taken of the thing, you see us.
That feels really special, seeing our instrument just hanging out there.
To see LEXI still in one piece is the biggest thing.
I wanted to know exactly how LEXI was doing. I wanted a photo every single day. The excitement of LEXI doing well, the lander doing well. Yeah, everything along the way was working.
Okay. Everybody join that, or how's that?
Let's get into it. So first one is, this is a really good place. People have been working on this idea for some of us, maybe 2 decades even. We're on the threshold of being able to make those measurements that we've been trying to do for a long time. As someone who now finds themselves on kind of the more senior side of the group and people here, this is incredibly rewarding. Space is a really hard environment, and landing softly is really hard. If we think back to the Apollo days, it took many, many, many tries even to hit the moon before we got to the moon, and then landing on the moon was hard. And it continues to be hard. There are a number of companies trying right now, and it's hard.
The first American space mission for more than half a century, aimed at making a landing on the moon, has run into an early technical hitch. The company behind the project, Astrobotic, says it's trying to fix the problem, but if it can't, the mission won't be able to proceed.
Just days after landing on the moon, the Odysseus moon lander is expected to stop communicating with Earth. Odysseus came down harder than expected, and one of its legs got stuck in a ditch, causing it to tip over.
Yeah, landing's hard. Landing is very hard, and so we'll see.
Should have skipped tutorial.
LEXI,
So you
this
see
is PJ, our
all
project.
of these pluses. So
Toe check.
this time.
Landing an instrument on the moon is something that few people get to be involved in. This is something that happens once in a lifetime.
It will happen in the middle of the night. There's really not much to do but wait and prepare for the case that it lands successfully.
Cade and I have the graveyard shift from 10 p.m. to 5 a.m., so that is our shift, and I imagine this whole room is going to be filled.
Our team will be here, of course, watching real time, anxiously, excitedly.
Welcome to the live landing coverage of Firefly's first road trip to the moon with our Blue Ghost lunar lander delivering NASA payloads.
The Lunar Environment Heliospheric X-ray Imager, or LEXI, will aim to capture the first global images of the magnetic field that shields Earth from solar radiation.
LEXI is riding on top of this machine that is going to land on the surface of the moon.
It's happening, it's real. It is also out of our hands, so there's a bit of nerves. It's Firefly's first attempt.
There's a lot of feelings. I'm worried.
For everything that needs to go right, there are 20 things that can go wrong.
It's like it's an orchestra, and everything has to go perfectly together to land onto the surface of the moon.
1 minute remaining in flight. Vehicle is converged on its commanded descent profile. 11 meters up.
10 seconds to contact. 5.
It's down. It's down.
Waiting on verification.
NASA, we are on the move.
Okay, all right, let's get to work. We're on the moon.
And then we landed.
Just hours ago, the Texas startup Firefly Aerospace making history, landing its Blue Ghost spacecraft on the lunar surface.
Today, it became the second to land a privately built spacecraft on the lunar surface and the first to land one upright.
And so we had 2 weeks of just furious and really intensive work looking at data as they came down, making modifications, making changes, making compromises. Right now we're 105 hours post-landing. It has been an intense 105 hours from the team.
I have never worked so much in my life, but somehow I feel like I can work more. To have something up there that we worked on from nothing, from an idea to something physical that you're then landing on the moon, it's just incredible.
It's hard to put into words, it really is. I will forever consider it so significant, just for me.
There are people out there who will be inspired by this.
LEXI is going to open a whole new avenue by which we can study Earth's interaction in our Goldilocks zone to our sun.
We now have this massive mound of data that's all come to the ground from the lander. It's just a treasure.
Blue Ghost 1 mission has always had a limited lifetime. It goes to the moon, trying to get to the moon during the lunar day as early as it can, and do all of the work it needs to do before the lunar night. When night falls, it gets very, very cold, and there is not sufficient heating to keep it alive through that.
So it's only sunlit for 14 days, and so that is the duration of our mission. We operated to the end. It was a couple hours before sunset. We turned LEXI on. We could see the temperature going down, down, down as the sun was going down, and then the sun set, and we watched this battery trickle down and down until it reached zero. And we got the official word that the lander had stopped talking to the ground. But it was a goodbye to a friend. It was goodbye to, yeah, a project we had been working on for 5 years and a friend that we had put there. It was powerful.